Okay, fun. Should be an exciting, wonderful day here in the neighborhood. Now, we're going to talk about a lot, but you'll be okay. Don't start crying or losing it. First of all, I'm going to talk about parallelograms. What things are true about a parallelogram? And we're going to do a lot of opposite sides parallel, right? 1, 2, what else? Let's keep going with the opposite thing. Opposite angles are what? Good.
With one diagonal.
Hold on. Diagonals bisect each other. Okay. One diagonal creates if you keep writing them down again, guess what? You might start remembering them. Consecutive angles are what? Is that good enough right there?
Yeah.
Is that everything? By saying it's a parallelogram, I'm saying all these are true, right?
Wasn't there a seventh one? Yeah,
Well, first, we're going to make a little thing, and we're going to go over here, and we're going to talk about rectangles. Now, why do you think I'm drawing the arrow from the parallelogram?
Because they're all parallelograms?
Every single rectangle is a parallelogram. So everything that's true about a parallelogram is true about a
Rectangle.
Okay, so let's back up a little. I forgot to back up when I made that point. So I'm drawing the arrow over here to rectangles. Do you guys know what actually makes something a rectangle?
Two sides being long.
No, actually that's not it. And it's okay that you don't know. It's a lot of times people really don't realize what makes it.
Sense of parallel.
Nope.
See, I thought it was just always because two sides were equal and the other two were equal. So,
What makes it a rectangle is that all the angles are 90 degrees.
well, aren't squares the same thing?
Who said a square wasn't a rectangle?
Squares are.
It's a special type of rectangle.
Rectangle isn't a square.
Nobody ever said a square wasn't a rectangle.
I had it right there.
That's kind of what I said.
A rectangle is a square, and a square is a rectangle.
You learn something new every day. That's really true though.
What you learned yesterday was.
That she should have been at school.
She wanted to see it. It's
You know what else is true about rectangles?
Opposite sides are congruent.
I already said that though.
everything up there. you already said.
Wait, but that's not, because parallelograms are rectangles.
Yes, diagonals are congruent as well. So everything up here that's said to be true is also true here, isn't it?
I haven't.
Let's keep the snide comments to yourselves. If you have something positive and nice to say, don't say anything at all.
I love geometry.
And don't lie either.
I'm good at
Now, so the diagonals are congruent. Guess what? That's what makes a rectangle. So how many things are true about a rectangle? Can anybody tell me?
8.
Ah, very good. Why 8?
Because all 6.
Because it's all 6 of these and these two. Ah.
What's 8?
Hmm?
There's 6 parallelism things.
A rectangle is a parallelogram. So all 6 of these are true, plus this one and that one. These are the only 2 things that are only true about a rectangle. Okay? These are the things just specific to a rectangle. But a rectangle is a parallelogram, so all of these are also true.
But those can't be.
We're going to go over here. Since I'm going over here separately, are the things I'm talking about here necessarily, or can they be a rectangle?
No.
No. Or not all of them are. Rhombus. Good old rhombus. He's a good old dude. Jolly old Saint Rhombus. First of all, do you guys know what makes something a rhombus?
All
If you didn't know, well, maybe you do know.
opposite angles are congruent.
Nope. The definition. When you say this is a rhombus, what are you saying? What makes it a rhombus?
Slightly slanted to the left.
What makes something a rectangle is that what? All the angles are 90 degrees, right? What makes something a parallelogram, the first thing, is opposite sides are what? Parallel. You know what makes something a rhombus?
Nothing's
All sides
All sides are
are
congruent. That's what makes something. I never said it wasn't.
Also.
You know what's also true about a rhombus? Diagonals are.
parallel.
How could the diagonals be parallel?
Well, I just was going off what you
The diagonals are perpendicular. Shh. You know what else is true? The diagonals bisect the 2 angles it intersects. Now, did I say that I already know the diagonals bisect each other because they do that in a parallelogram, don't they? But you know what the angles also bisect here? That angle opposite it, that it goes from one side to the other, cuts those angles in half. That's what that means, isn't it? So diagonal is a segment, right? So that means when we talk about this, that means this segment is going to cut the other each angle. And example of a picture of that would be right here. This diagonal cuts this angle in half, does it not? And it also cuts what? This angle in half. This angle separately. Now, I never said these were all congruent, right? But this other diagonal cuts the 2 angles it intersects in what? Okay, so that's true about them. Okay. Now, let's say Mr. Rhombus and Mrs. Rectangle got married. They then proceeded to decide they wanted to have kids.
Square.
You know what their kids would be? Nope. It would be a square. You know why?
Because square,
You know what the definition of a square is?
A rectangle and a rhombus.
All angles are 90 degrees, and go over here to rhombus. All sides are what?
Is that the only rule for the square?
Yup. But there's actually how many things true about a square? Nope.
7.
Nope.
12.
5.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
12.
Take away 2 puts me at 9, 10.
And why would you take away 2?
Because aren't this one and this one the one down here?
Oh, the same thing?
Yeah, so 10. So by saying something's a square, I'm saying 10 things are true. These 10 things are true. That's pretty cool, huh?
Only what? You missed me.
I missed everyone.
Especially me. You know that's all. Did you pick Sean?
You know, sadly, I didn't even notice you were gone. I'm sorry, I just like.
Oh,
I did that.
Why would you say that?
I didn't.
Hey, don't worry. He's not one of the ones you wanted to notice was here, and you were here anyway, right? I mean, so a mission accomplished, right? You were such a turd. Why would you say something mean and ugly like
I
that?
didn't mean to be like mean, but.
Didn't I just say if you don't have anything nice to say, don't say anything at all?
Yes, exactly.
Didn't I just say that?
But that isn't mean.
Yes, it is. Just because it's the truth doesn't mean it's not mean.
Makes them feel left out.
I mean, if you annoy the hell out of me and I don't say it, but if I said, hey, you annoy the hell out of me, it may be the truth. But if that doesn't mean it's not mean.
But that means that I'm so concentrated on your work that I'm too busy to notice anybody here. So technically, it's a compliment towards
So
you.
you didn't notice she was here or anybody else was here, right?
Yeah.
There you go. Okay. It wasn't you. He didn't know anybody else was here.
Does he know she's not even paying attention? I thought I was the only one here.
Guys, that's pretty easy, isn't it? So what do you think we're going to do? Apply all those facts to write some equations, things like that. Now, there's a couple of things, extra things you need to write down from each section. As far as tests for a parallelogram. All of these could be tests for whether something's a rhombus. If these are true, then you know it's a rhombus, right? If these two are true, you know it's a what? Rectangle. Any one of these two are true, you know it's a rectangle. Any one of these three are true, you know it's a rhombus. If this is true, you know it's a square, right? However, there is actually another deal here. Like, for instance, there's this one that says if a pair of consecutive sides of a parallelogram are congruent, then you know it's a rhombus. Now, what the key words here are parallelogram and congruent. Since we're saying that since it's a parallelogram, we know the opposite sides are congruent, right? So if these two are congruent, but that's also then congruent to what? And this is also congruent to what? So that's kind of one of those theorems that, yeah, it's true, but couldn't you get that way from just looking at any one of the other theorems? It's kind of a useless shortcut if you ask me. So don't fret yourself too much on it. And these are all ones saying, hey, if the diagonals are perpendicular, then you know you have a rhombus, because that's one of the rules for a rhombus, correct? Here, if the diagonals bisect the opposite sides, you know you have a rhombus, because that's one of the rules for a rhombus. So what I would focus on, and this is what kills people about this. You know, I've helped baseball players with this, guys that, you know, everybody wants to be able to look at it and know everything that's true. Well, you're not going to. You need to use this when you're doing these problems to say, are any one of these facts going to help me get what I need? Does that make sense? So you have this in front of you. Now get your red books out, and we'll turn to like some problems on 6-4.
How come you never sign like workbook pages instead of like book?
Because it's all.
Because these are study guide intervention. They're the kind of basic ones. If you're looking at this one, first of all, they said this is a what? So we know there's 8 things true. They tell us that AE is what?
36.
They tell us that CE is what? Find X. I have a question for you. Did I need to know this was a rectangle to be able to solve this one?
Yes.
No, you didn't. I could have said it was a parallelogram because it's a parallelogram where the diagonals what? Bisect each other, right? So whether this was a rectangle or, as long as it was a what? Parallelogram, I know that 36 is equal to what?
2x.
Minus 4. Because the diagonals always what? Bisect each other. And, you know, yes, that pops into my head because I've taught it a few years, haven't I? Is it supposed to necessarily pop into your head? Not necessarily, but don't you have something like this to tell you all the facts about each one? And you can move up? So I would have something like this handy, because every time you use this or look up one of these facts, it's going to what? Help you remember it just a little bit better, isn't it? Okay? Once you knew that and you labeled it, it's pretty easy. Well, the next one, they say BE is 6y plus 2. CE is 4y plus 6. Now, that's that one right there. So, how about I redraw this a little bit bigger? It's a little hard to see. Is this B?
Yeah.
Is this E?
Yes.
C?
Yes. A.
Okay, they tell us that BE is what?
6y plus
They tell us that CE is what?
4y plus 6.
Now, if this was just a parallelogram, I would not be able to do this problem. Because all I know as far as a parallelogram is concerned is what? Can anybody help me? That the diagonals bisect each other, correct? But so that would mean I could say this is equal to that, but this doesn't necessarily have anything to do with that if it's just a parallelogram. However, the nice thing about rectangles, what's also true? The diagonals are congruent. So if this whole thing is congruent to this whole thing, then when it cuts itself in half, aren't all the halves going to be equal? So if this is 6y plus 2, this is what? 6y plus 2. Everyone agree? So as a result, now my equation for that one can be 6y plus 2 is equal to 4y plus 6. And the reason I could do that is because this was a what? And in a rectangle, the diagonals are the same length. So you know that's the only one where, other than a square, where they're the same length, is a rectangle. And it's because of that 90-degree angle, they end up being the exact same length. When you tilt it one way or the other, it makes one diagonal bigger than the other, or one smaller than the other. Okay? So now you've got this. You find x. What do? Subtract 2. What's y equal to? How are we on that? Does that make sense?
Let's do that problem knowing the parallelogram rules.
Yeah, if it was just a parallelogram, you wouldn't be able to do that problem because this wouldn't necessarily be congruent to what? That. So all you would know then is that this half's congruent to that half, and this half separately is congruent to this half. But since it's a rectangle and this length is the same as this length, then the diagonals, you know, if you wanted to write another theorem, you could say in a rectangle what? The diagonals are cut into 4 equal parts. When the diagonals intersect, they cut it into what? 4 equal parts. Isn't that another, you know, you could write that underneath there. Cut each other into what? 4 equal parts. You can add that to your list if you want to, because that's another thing that's true. If you ask me, that's more, I don't know, more useful than some of the other stuff, isn't it? Useful to know that. Anytime you got a rectangle, the diagonals will cut themselves into, you know, all 4 parts made are equal. However, if you drew, I'll show you the difference. If I drew a parallelogram, parallelogram all it means is that these are what? Parallel? Would everyone agree?
Yes.
Now just look at the length of that diagonal compared to that diagonal. Is this one obviously bigger than the other one? Does it, you guys see that? If I zoom in a little more? And the reason is because it's kind of slanted to the side, so it makes one diagonal bigger than the other one. However, when it's 90 degrees and they're straight up and down in both places, you can see how the lengths would be the same, right? So that's why in just a parallelogram, all you can say is that's congruent to that and that's congruent to that. But in a rectangle, what happens? They all 4 end up being what? They all 4 end up being congruent, right? Does that make sense? Okay. So, kind of some things about rectangles. Let's jump ahead and do a just a quick example with some rhombi. What I do want to add to the rhombus notes, and this is one thing I forgot.
Strongly dislike this.
I'm not a fan that they do this to you, because we're going to do a section on this and go into it in more detail, but you're coming into this class assuming that in Algebra 1 you did some Pythagorean theorem. Remember, guys, the hypotenuse is the one opposite the what? Right angle. So c squared is equal to a squared plus b squared. Come in. Golden ticket for who? Chris Hale. Okay? So you need to remember this. The reason I say this is because when you have a rhombus, what does it say about the diagonals? They intersect to form what? Right angles, correct? So what do you have 4 of here? 4 right what? 4 right angles and 4 right what kind of?
Triangles.
4 right triangles. So they may ask you to use Pythagorean's theorem to find.
Can you explain the c squared equals a squared plus b squared?
Okay, what you got to do is this is just how the sides of a right triangle always relate to each other. The biggest side, which is always the one opposite the right angle, that's why I like to tell people, that the hypotenuse, the one opposite the right angle, so anytime you see that right angle sign, think of it as the front of an arrow pointing to, here's your C here for this one, and what? That would be your C for that one. This would be your C for this one, and this would be your C. Okay? Once you find that one, you know that's the one that the other 2 squared are added together are equal to. Once you find that one, you're okay. It doesn't matter whether this one's A and this one's B, or this one's B and this one's A, as long as you put the hypotenuse in the right spot. So, with that in mind, back to some of these problems over here, they have the ability to do that to you. First of all, let's look at this one. The measure of angle ABD is 60. Find the measure of angle BDC. The measure of ABD is 60. Find BDC. Okay, that's all they gave us. And what they told us is that this is a what? Rhombus. Telling you that this is congruent to this, is congruent to this, is congruent to this. What else does it tell you?
Two equal.
Now, let's see if I've zoomed in too much. The diagonals are what? Perpendicular, and the diagonals bisect the two angles intersect. So we know that each one of these angles are 90 degrees, correct? And we know that these are cut in half. So if this one's 60, what's this one?
60,
If this one's 60, what's this one?
60,
What's this one?
60.
Oh, I found my... So what is the answer here? 60 degrees, isn't it? Because that was my question mark?
Come on, like, are you using it?
Yes. Is that big a deal?
I thought you were using it.
Okay. Does everybody see that? Okay, look at number 2. I'll erase this and just leave this big. Everybody has number 2 in front of them, right? Where I don't need to pull it back up over here. Right? Okay, number 2 says AE, A to E is 8. Okay. Find AC. AC is the whole thing, isn't it? What do we know about the diagonals here? What do they do? Bisect each other. So if this one's 8, what's this one? So what's this make AC?
16.
That was one where it didn't have to be a rhombus, it just needed to be a parallelogram, didn't it? Let's look at number 3. If AB, that one's this right here, is what? 26. BD, that's the whole thing from here to here, right, is 20. Find AE. Guess what?
I'm confused.
I'm sure you are. How in the world am I going to get this? Well, let's just start working down. If this is 20, what do you know this is?
10 and
10 and 10. If it is a rhombus, what do we know that the diagonals make? Right angle. Is this, we'll call it X, what they want me to find? So I'm going to redraw this down here.
Oh, okay.
I have a right angle right here.
So it's 10
The
squared
this one's what? What's this one?
26.
6,
Everybody with me? You see how I'm moving this from down here to down here?
Yes.
What is this one?
10.
What is this one?
X,
10 squared plus x squared.
So what do you think they want you to do here?
Pythagorean.
Use Pythagorean's theorem. Okay? First thing, find the what?
Hypotenuse.
All you got to do is look and see where the right angle sign is pointing. Where's it pointing?
26.
So 26 squared is equal to, now just 10 squared plus x squared. I don't expect you to know what 26 squared is in the back of your head. Could someone please put that into a calculator for me? Is equal to 10 squared is 100 plus x squared. What would be your next step here?
576.
Subtract 100 from both sides. Please don't skip steps. X squared is equal to
576.
576. So is that what the length of that side is? Is it 576? Does that make sense?
You have to square
What am I missing? I have to take the what?
square root.
Square root of both sides. Because the square root of x squared is x. Okay? So what is square root of 576? Does it come out even? Huh? Is that right?
yeah, 24.
Is that what it came out in your calculator? Good. That's probably it. You may get decimals there, you may not. If you get decimals, round it to the nearest hundredth or something. Okay? Any questions? That's not that terrible. I know it's weird. I know you haven't done it in a while, but the moral of the story is if you can just realize that that arrow is pointing at what? The c squared, the thing that you put on one side, you just square the other two and put a plus sign between them, right? And then you solve it just like a regular equation, and then at the end, take the what? Because really, when it's all said and done, isn't this just like a regular equation? The only difference was, you know, at the point where you got x equal to, you actually had x what? Squared equal to, the one step you add is taking the what? Square root of both sides. Okay? Now, your assignment. And you're going to have 2 days to work on yesterday's and today's. Now, you need to use your time wisely. I mean, I'm not going to lie. It'll jump up on you if you don't. Okay, does anybody else need to write that down? Or can I zoom out and put your assignment up here? Don't whine because you see all this long, huge thing. Is that actually a good thing most of the time? What does that long, drawn-out list usually mean?
Sure.
That I'm cutting out some problems, right? I mean, I could just say do numbers 1 through 56. I mean, I don't know about you guys, but I don't know which one's a better deal, 1 through 56 or 1 through 60, or is it the way I did it? It always makes me chuckle when people get all bent out of shape.